Now we'll explore how to find slope of a tangent line and relate it with the derivative of the function. In this particular exercise, we'll actually find slope of tangent line for all these functions which are represented by y equals to x to the power of n at the point 1, 1, right? So if x is 1, then anything to the power of 1 is going to be 1. That's the whole idea, right? So we have different kinds of functions here. To get the slope at a point, what we need to do is basically draw a tangent line, right? So at this point, I can draw a tangent line which could be like this. Do you see that? So let me just draw a tangent line. You have to do a neater job. I'm just showing you how to do it. And then what we see here is that we can now make a triangle, correct? So this is a good triangle which we have, and from this triangle I can write slope m is change in y over change in x. So the change in y is from 1 to 3, which is 2, and change in x is from 1 to 2, which is 1, and therefore the slope is 2. You will notice that this particular graph is of y equals to x squared, and slope of that at the point which is 1, 1 is 2. Now let's get to the next one. Now here if I draw a tangent line, then what do I get? So I have to draw a tangent line here. So if you take a scale and then do it, it will be kind of like this, right? So here what you notice is this is not so accurate, but in any case, let me use a different thing. So if I draw this and rise over run, then what I notice here, actually this is not a very good graph. This is not tangent. So let me redo it. It's not a good graph. So it doesn't look like a tangent, right? So it is kind of weird. So let me draw another line here. Okay, so this is better estimate. Okay, so I'll continue with the same point, but the thing is this. So what you find is the tangent, this is better tangent than that, of course. The slope of this now is change in the y value, which is from 1 to 4, so which is 3, and from 1 to 2 it is 1. So in this particular case, we get slope as 3, right? 3 over 1. And you'll find that this graph is actually the graph of x cubed. Do you see that? So a power function slope at 1 is actually the power itself. That's very important to understand. Here, if I draw the tangent line, let's do it. So you get a line like this, correct? So that becomes the tangent line. Now since it is dropping down, so the rise here, delta y over delta x, is minus 1 over 1, which is negative 1. Perfect? And in this particular case, this graph is actually of y equals to x to the power of minus 1 or 1 over x. Do you see that? So the power and tangent at this point is same. Perfect. Now here we have a graph where we'll again draw a tangent line. So what we have here is, so if I draw a line here, it is kind of going like, let me just draw. Okay, so that's the tangent line, correct? So now if I make a triangle, I get what? This is what I get, right? So in this particular triangle, I notice that change in y is 1 and change in x is 2, right? From 1 to 3. And therefore, in this case, the slope is 1 over 2. Since it is rising, it is positive. And the graph here is y equals to square root of x. Do you see that? X to the power of half. Perfect. Now, in this particular case, let me draw a tangent. So what we get here is kind of like this. Let me just go like this. Okay, this is good. Now, if that's the tangent line, the slope is negative 1. This is y, change in y is negative 1. And the run is of 3, correct? So in this particular case, we get slope m equals to negative 1 over 3. And you will notice that this graph is of the function y equals to x to the power of minus 1 over 3 or 1 over cube root of x. Do you get an idea? Okay. Similarly, the last graph, if you draw the tangent here, then you will get this function is y to the power of x 2 over 3, right? So what should be the slope? Slope should be 2 over 3 at the point 1, 1. Do you see that? So draw the tangent and you'll figure out that when you draw the tangent, rise is of 2 and run is of 3, right? So if you do this tangent, then you'll get a line which is kind of like this. And if you form a triangle, then the run is of 3 and the rise is of 2. So you said delta y is 2 and delta x is equal to 3. And that is how from the tangent you get the slope. Now this is very important exercise, and you will soon learn in the next chapter that the derivative of y to the power x to the power of n, and we could write like this, y dash is n x to the power of n minus 1. So this n, when x is 1, is same as the exponent. And that's the reason why our slope for the tangent line approached the value of the exponent, right? So I hope that's a very interesting take from this particular video, and this will give you an idea about how the derivative's value should be for a given function, correct? So let's take one more example where we are talking about just looking at the graph of the function and then answering. Now this helps to understand the whole chapter, right? Now the question here is, identify the points where the function is not differentiable. So we have done this. It should be clear for you. So you should identify the points where the function is not differentiable. So let me mark those points. So here the function is not differentiable at this point, since it is a corner. From left seems to be a tangent of minus 1 slope. From right it is plus 1. Here this again is a cusp, not differentiable. Here a discontinuity. Here again a discontinuity, right? So those ones are very clear. So this is a corner, right? Here we have a cusp, correct? Here we have a discontinuity. Now, when there is a discontinuity, you don't know where to draw a tangent, correct? So you can't draw a discontinuity. You cannot draw a tangent here, right? So that is ambiguous, right? So it is not differentiable at this point. Here, it is a vertical asymptote. And the point x equals to minus 2 is not in domain. Do you understand? And therefore, the function is not differentiable at that point. The function is not differentiable because the point is not in domain. How can you draw a tangent line? But I want you to give me the reason for what I have left here. Why is this function not differentiable at plus minus 4? So whenever we talk about differentiability, we're actually approaching from both the sides. It's very important to understand. So you have to find a limit of the function as you approach from the left side and from right side. Now in this case, you cannot approach from the left side, right? So therefore, it is not differentiable at plus and minus 4. Do you understand? That is the reason, correct? So whenever you have a starting point of a function, then you can say it is differentiable in between, but not at 4 and plus minus 4. So it is not differentiable at x equals to plus minus 4, right? So because you cannot approach from the outside, that is the whole idea, right? And the blank space here is for you to sketch a function which is not differentiable at some point, right? Now to give you an example, which is not here, I will use a function which is kind of like this, right? So if it is vertical here, kind of, do you see this? Now we do have a continuous function. It is not differentiable at x equals to 0 since we have a vertical tangent. Correct? So if you have a vertical tangent, which is also the case here, in that case, the function is not differentiable. Perfect. So that is how you can answer these kinds of questions.